All right, so this lesson is about how to do reflections on a coordinate plane. And you've already seen reflections on just a blank white sheet of paper, and you've been doing it with your compass. And you've learned that reflections are where you take a pre-image and you flip it over a line such that when you connect the points of the pre-image to the points on the image, the line of reflection is the perpendicular bisector. In other words, you have to go in a way that's perpendicular to the line of reflection. And that's way easier to do on a coordinate plane. So that's what we're going to talk about today. So one thing we can do is reflect over the x and y axes. So I want you to take a second. I want you to draw DAN, plot it on your grid, and then we're going to flip that over the x-axis and over the y-axis. So take a second, plot it now. All right, so now you see DAN on my screen. DAN should also be on your screen. Now we're going to plot D prime, A prime, N prime, and that's going to be the image of Dan over a reflection in the x-axis. So remember, reflections, lowercase r, and then down here you have the axis of the line of reflection. So we're going to flip over the x-axis. The x-axis is this guy right here. So when we flip it over the x-axis, what's going to happen is D, flipped over the x-axis, well, stays right there because it's on the line of reflection. So D and D prime are actually the same point. Now A flipped over the x-axis, I'm going to count to the x-axis, and then I'm going to count away from the x-axis. So 1, 2, 3, 1, 2, 3. There's A prime. And then if I do n, n was 8 up, so I need to go 8 down. 1, 2, 3, 4, 5, 6, 7, 8. So there's a D prime, A prime, N prime. And if I were to connect A and A prime, wouldn't they be perpendicular to the line of reflection? They absolutely would. So if I connect these with as straight of a line as I can draw here, there's D prime, A prime, N prime. Now, you have to state coordinates. When it comes to the Regents exam, when it comes to your quizzes and tests, whenever you do a transformation on a coordinate plane, you always need to state the coordinates of the image. So let's look at the coordinates now. So D, state exactly where it was, so that's still 4, 0. D prime, pardon me. A prime, flipped over the x-axis and came down. So it's 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So now A prime is 7, negative 3. And if we look at N prime is on the y-axis, so its x-coordinate is 0. And we went down 8, so it's 0, negative 8. So now let's see what happened here. D was 4, 0, it's still 4, 0. A 7, 3, now it's 7, negative 3. N 0, 8, 0, negative 8. What happened to the points? Well, the x-coordinate stayed the same and the y-coordinate got negated. So the rule for reflecting over the x-axis is that x stays the same, y becomes negated. In other words, keep x, negate y. And remember, negate means negate, not make negative. It means negate. So if it's positive, it becomes negative. If it's negative, it becomes positive. So keep x, negate y. All right, now, I want you to try this one on your own. I want you to take DAN right here, flip it over the y-axis. So take this triangle, flip it over that way, plot the new triangle, and state its coordinates. Press pause. Go now. All right, hopefully you flipped it over with the y-axis. Let's see if yours looks like mine. So when I look at the graph, it flips over the y-axis. It comes over here. And the coordinates, when you flip it over the y-axis, well, D turned into D double prime negative 4, 0, A double prime negative 7, 3, and N stayed the same because it was on the line of reflection, so N double prime is still 8, 0. So 4, 0 became negative 4, 0. A became from 7, 3 to negative 7, 3, and N stayed the same. What happened? The Y's all stayed the same, and the X's got negated. I just realized I wrote this guy backwards. This should say 0, 8. My apologies. So the X's all became negated, and the Y's stayed the same. So coming down here, the rule for reflecting over the y-axis is negative x, y, negate x, keep y. Okay? And then complete the sentence. If a point on the pre-image is on the line of reflection, it stays put. It stays put. That's what happens. All right, let's go on to the next page. Now, you don't have to reflect just over the y and the x-axis. You can reflect over lines like x equals -2, or y equals -1, or x equals 17, or anything like that. You can technically reflect over anything you want if it's a line. Now, one of the things you need to remember, though, is we're going to have to sketch in that line of reflection. So x equals lines go through the x-axis, which makes them vertical lines. X equals lines are vertical lines. Y equals lines are horizontal lines. Okay? So, back up here. I'm going to take Jen. I'm going to draw on the line x equals -2, and then I'm going to reflect it. So take a second, plot Jen. All right, so if you plotted Jen, it should look like this. Now, I'm supposed to state the coordinates of J prime, E prime, N prime, the image of Jen after a reflection over the line x equals -2. So x equals -2 is right here. I'm going to draw a vertical line right there. Now, my lines aren't so straight, so I'm going to have this help me out here. And I'm going to go, ooh, here's my vertical line. Now, if I'm you, I would be dotting this. So I'm actually going to come in here and take this guy, and I'm going to try to make it dotted. You should do the same. Again, you don't have to, but it's just one of those things we like to do to make sure we know what are we reflecting over and what's actually a line on our image or our pre-image. In any case, you want to draw in some kind of dotted line here for x equals -2, and then we're going to flip over that line. So I'm going to now take my point, N, and I'm going to flip it this way over the line. So I'm going to count 1, 2, 3 to the line, 1, 2, 3 across. There's N prime. J1, one more. There's J prime. And E1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And there's E prime. And then I'm just going to connect the dots, and I will have my image. So this triangle flipped over that line gives me this triangle. All right, now I have to state the coordinates. Now what's important here is when you state the coordinates of J prime, E prime, and N prime, that you're counting your coordinates from the origin and not from this line you just drew. So J is left 1, up 1. So J is -1, 1. E prime is 1, 2, 3 to the right and 2 down. So 3, -2. And N is 1, 1, 2, 3, 4, 5, 6, 7, 8. So N prime is 1, 8. All right. Then we're going to flip over the line y equals -1. So I'm going to draw in y equals -1 with you, but you're going to flip it yourself. So let's draw in -1 together. I'll do it on here. And let's see, y equals -1. Well, here's the y-axis. -1 is right here. So y equals -1 would be this line right here. And I'm going to very quickly change that to dotted. And I want you guys to pause this and flip over that line. All right, so pause and flip over. We'll come back and check. All right, so if you flipped over the line, you should see an image that looks like this. The unique part about this image is that the line of reflection went through the shape. That's okay. You still reflect everything point by point. E flips over and comes up here. J flips over, N flips over, and then you get the coordinates of -3, -3, -7, 0, and -5, -10. All right, now last but not least, we've been dealing with vertical and horizontal lines only. We have not yet dealt with diagonal lines. We're going to do that here. So first thing we have to do is we're going to draw the line y equals x. And if you think of y equals x as it being in slope-intercept form, you have a slope of 1 and an intercept of 0, which means this is a line that goes through the origin and then goes up 1 over 1. So it starts at the origin, up 1 over 1, up 1 over 1, and continues like that. So it goes like this, and it does the same thing in the other direction. It just extends itself. So I'm going to do that here. You do the best you can at home. There's the line y equals x. That's the line we're going to reflect over. Now, we have to plot negative 1, 2, 4, 0, and 3, 3. So take a second, plot it, and then restart the video. All right, so you plotted the triangle LJV. It looks like this. Now we need to flip over this axis, but we need to do so in a way that's perpendicular. So when I try to flip J across, I need to follow in a line that's perpendicular to the yellow line. So when we count, we actually count diagonally. So from J to the yellow line is 1, 2 diagonals. 1, 2 diagonals puts J prime up here. L goes through half a diagonal, so then I go through another half diagonal. And V goes through 1, 2, 3 diagonals, 1, 2, 3 diagonals. There's V right there. Did I do that correctly? 1, 2, 3, 1, 2, 3. Yep. And now here's L, J, V up there. Now I need my coordinates. So L's new coordinates, L prime is -2, -1. J's new coordinates, we went over 0, up 4. And V's new coordinates are now -3, 3. Okay, what happened? Well, -1, -2 became -2, -1. 4, 0, 0, 4. 3, -3. I forgot to put my prime on V. -3, 3. What happened? Well, these swapped, these swapped, these swapped. So the rule for reflecting over y equals x is that xy becomes yx. In other words, swap the coordinates. Okay, you want to swap the coordinates. Now, if we want to do the same thing, but we want to flip over y equals -x, I'm going to take this guy. I'm going to draw y equals -x. Y equals -x would have a slope of -1 and pass through the origin. So that means I'm going to go up 1, left 1, and it's going to look something like that. So there's y equals -x. I'm going to make it yellow. And then I want you to plot ABC, and I want you to now count diagonally on your own. So plot ABC, and then count diagonally on your own. Figure out if you can find the points, and if you're feeling really good, try to think of the rule yourself. All right, so if you look at this one, I'm going to show you the picture first. Here's what it should look like. Here's ABC. When you count diagonally, B is going to stay where it is. A is going to go 1, 2 and a half, 1, 2. There's A prime. And then C is going to go 1, 2, 3, 1, 2, 3. And there's C prime. So your picture should look like that. And your coordinates for that picture should look like, should look like this. A became -4, -1. B 1, -1, and C 0, -6, or A prime, B prime, and C prime should have those coordinates, pardon me, not A, B, and C. Now, if you look at A prime, B prime, and C prime, 1, 4 became 4, 1, but both negative. 1, -1 became 1, -1, and then, let me fix that, and then C, 6, 0 became 0, -6. So on A and C, it kind of looks like we reversed the order and negated them both. But on B, did we do that? Well, yeah, we did, because if I reverse the order, it becomes -1, 1, but then negated, I get 1, -1. So long story short, the rule for reflecting over y equals -x is -y, -x. You swap and negate the coordinates. All right, so I want to wrap everything up here. So basically, here's what you need to know. If you reflect over the y-axis, you negate x. Sorry, I don't know what's happening here. Negate x. If you reflect over the x-axis, you negate y. If you reflect over y equals x, you swap the coordinates. If you reflect over y equals -x, you swap and negate the coordinates. And if you reflect over some sort of x equals a number or y equals a number kind of line, you just need to draw it in and count them. All right, so that's reflections on a coordinate plane. I cannot emphasize enough, it's best to just memorize these two rules because it's so hard to count diagonally. Just remember y equals x swap, y equals negative x swap and negate. I hope you've loved listening to me for the last 15 minutes. Enjoy your evening, your day, whatever time it may happen to be for you. Maybe the morning on the bus on your way to school. I hope it's not that. Enjoy your day. Good luck with your transformations as we move forward. Bye bye.